Hello friends, once again welcome to our this new video. This is video number 18 based on the chapter solutions. In this video we are going to learn one of the important and interesting aspect, that is what the phenomenon of reverse osmosis. Try to understand. So this phenomenon of reverse osmosis can be explained well with the help of the such type of schematic representation or with the help of this diagram. We have already studied the osmosis. We know the flow of solvent molecules into the solution, or the net spontaneous flow of solvent molecules into the solution through the semi-permeable membrane is called as osmosis. That is what the flow of the solvent molecules from the pure solvent into the solution, or the flow of solvent molecules from lower concentrated solution to the higher concentrated solution through the semi-permeable membrane is considered as the osmosis. The reverse phenomenon, or in this case when this osmosis is prevented or stopped by applying the external pressure over the solution side, in that case the reverse process occurs. That is what, when the external pressure applied from the solution side. So in this case here, that is what a fresh water, that is a pure solvent or fresh water, and the salt water, that is what the solution, salt water or solution, that can be separated by a semi-permeable membrane. So we know the osmosis is the flow of solvent molecules into the solution or into the salt water. But reverse to this, when the external pressure is applied, look at this, that is what, when the external pressure is applied from the solution side, then what happens, that is, with the external pressure is greater than that of the osmotic pressure, the solvent molecules from the solution, try to understand, the pure solvent molecules from the solution passes or moves into this fresh water or into the pure solvent. So this phenomenon is considered as the reverse osmosis. Try to understand what is the reverse osmosis. See here, that is the when the external pressure which is applied from the solution side is greater than that of the osmotic pressure pi, at that time the flow of solvent, that is the pure solvent molecules from this seawater or from this salt water or from this solution into the pure solvent or fresh water occurs through the semi-permeable membrane. This is called as reverse osmosis. That is what the phenomenon of osmosis can be stopped or can be prevented, and in that case, that is the reverse flow of the solvent from the solution side into the fresh water or into the solvent occurs by applying the external pressure, that pressure that is greater than that of the osmotic pressure. So this is called as the reverse osmosis. In our day-to-day life, we will use the pure, in order to get the pure water or water for the drinking purposes. So we will use the filter, that is as that of the Kent, like that. So in that case, this reverse osmosis, this technique is used there. That is what mineral RO, or we know due to the availability of hard water, that is most of water is available in ocean or in sea, so that can be converted into the soft or drinking water by the reverse osmosis. So at home we will use the machines for the purification of water, that is called as filter, Kent, like that. And similarly, the water from the ocean or sea water that is hard water, contains many more minerals. See here in this diagram, that is a reverse osmosis that can be explained with the help of this diagram, the schematic representation of actually how the reverse osmosis occurs. So what is that? In one compartment, seawater, that is the salty water, is taken, and in another compartment, that is what the fresh water is there, when this is separated by semi-permeable membrane. So naturally the phenomenon of osmosis occurs, that is flow of solvent molecules into the solution. But when the external pressure is applied on the solution side or seawater side, salt water, and if this pressure is greater than osmotic pressure, the reverse phenomenon occurs. This is called as the reverse osmosis, which is useful for the purification of the seawater, and that water can be now used for the drinking purposes. So in this way, simple phenomenon that is called as the reverse osmosis, but it is nowadays it is very much important one, as we are facing the problem of the drinking water. So in order to make available the drinking water, so this reverse osmosis technique is used there. So that is all regarding to this simple phenomenon. Then after this, we have to learn the one more important aspect or article, that is what? The Van Hoff's factor. So that is the last article or last aspect from this topic. So before studying that Van Hoff's factor, one should have to watch all the videos from this topic solution. So in the previous videos we already studied, that is the qualitative properties for the non-volatile solutes. Qualitative properties for the non-volatile solutes. So one should have to learn in details regarding to the lowering of vapor pressure, elevation in boiling point, depression in freezing point. While studying the Van Hoff's factor, we have to study the osmotic properties for the electrolytic solutions. So in the previous videos we have seen the non-volatile and volatile solutes, then furthermore electrolytes and non-electrolytes. So up till now the qualitative properties are studied for the solutions of the non-electrolytes. After this we have to study, that is the qualitative properties for the electrolytic solutions, and the Van Hoff factors deals with the study of comparison between the qualitative properties of the non-electrolyte solutions and the qualitative properties of the electrolyte solutions. The comparison of this is studied in the Van Hoff's factor. So I will request all of you, please watch all the videos based on this topic, then it is easy to understand the Van Hoff's factor. That is also the very important aspect. So we stop here. Thank you.